Imagine trying to build a jet aeroplane, but instead of using high-tech turbines, you just shove a massive liquid-cooled V12 piston engine inside a giant aluminium pipe. Sounds completely mad, doesn't it? Well, in 1941, Italy used exactly this bizarre method to fool the world into thinking they had won the jet race. But underneath the sleek skin of the Caproni Campini N.1 was a thermodynamic paradox that was doomed from the start. Today, we are stripping back the fuselage to look at history's most brilliant dead end, the motorjet. To understand why anyone would put a V12 inside a jet, we have to look at the massive engineering wall facing designers in the late 1930s. The theory of the pure turbojet was already well understood. A compressor sucks in air, you mix it with fuel, ignite it, and the expanding exhaust gases drive a turbine. That turbine spins the compressor, keeping the whole loop going. It is a beautiful, self-sustaining cycle. But there was one catastrophic problem: metallurgy. The turbine blades, which sat directly in the path of the exhaust, had to survive 800 degrees Celsius firestorms while spinning at 20,000 revolutions per minute. Have you ever tried to run a mechanical component so hot and so fast that it literally liquefies its own parts? That was the reality. The metal simply kept melting on the test stands. Enter an Italian engineer named Secondo Campini. He looked at these melting turbines and made a radical decision. He binned the turbine entirely. If the only job of the turbine was to spin the air compressor at the front, why use fragile, heat-warped blades? Why not just use raw, mechanical, brute force? Campini's solution was the thermojet, or the motorjet. The aircraft built to test this, the Caproni Campini N.1, was essentially a flying wind tunnel. Inside the nose of this hollow tube, Campini mounted a 900 horsepower Isotta Fraschini liquid-cooled V12 engine. But here is the kicker. If you looked at the front of the aeroplane, there was no propeller. The V12's sole purpose in life was to spin a massive 3-stage variable pitch axial compressor located immediately behind the engine block. Now, let's trace the airflow, because this is where the engineering gets fascinating and a little bit messy. As ambient air was sucked into the circular nose intake, it had a hurdle to clear. Because that massive V12 engine was entirely enclosed inside the fuselage, it needed serious cooling. So, the incoming air first had to push through a conventional annular radiator, just to extract the heat from the V12's coolant jackets. This meant the air was already being preheated and losing pressure before it even reached the compressor. Once past the radiator, the V12 forcefully spun the compressor blades, accelerating and densifying the air. This highly pressurized flow was then channeled past the cockpit and down the long, hollow tail section of the airframe. At the very rear, Campini engineered what was effectively an early afterburner. He installed a complex ring of aviation fuel injectors. Fuel was sprayed directly into this rushing wall of compressed air and ignited. The violent volumetric expansion of those burning gases generated a high-velocity jet efflux, which shot out of a variable area exhaust nozzle, pushing the aircraft forward. Mechanically, it was brilliant. Campini successfully separated the compression stage from the combustion stage, entirely sidestepping the metallurgical nightmare of the turbine. He had built a jet engine out of 1930s car parts. But as we'll see in part 2, outsmarting metallurgy comes with a devastating penalty in physics. On the 30th of November 1941, the impossible happened. The Caproni Campini N.1 roared down the runway at Linate Airport in Milan and took to the skies, completing a 470-kilometre flight to Rome. When it landed, it was met by Benito Mussolini, and paraded as a supreme triumph of fascist engineering. To the international press, who knew nothing of the top-secret turbojet flights already happening in Germany, this was an aerodynamic miracle. Italy had seemingly cracked the jet age. But behind the propaganda, the engineering reality was a disaster. Stripping away the political theatre reveals a profoundly disappointing truth. The N1 was abysmally slow. Even with the Isotta Fraschini V12 screaming at maximum continuous power, and the three-stage compressor working flawlessly, the aircraft struggled to exceed 200 miles per hour in pure compressor mode. Let that sink in. This futuristic, propellerless wonder weapon was actually slower than most fabric-covered biplanes of the previous decade. Why? Because of the brutal mathematics of weight and drag. That V12 engine alone weighed over 700 kilograms. When you add the weight of the massive compressor, the liquid cooling systems, and the aft combustion chamber, the aircraft was carrying the weight of a tank to do the job of a sports car. Furthermore, forcing all that intake air through the restrictive matrix of the V12's radiator created immense internal aerodynamic drag. The engine was choking its own airflow. To achieve anything resembling combat speeds, the test pilot was forced to engage the rear burners. This is where the thermodynamics truly fell apart. Think of the Campini system like taking a giant petrol-powered leaf blower and attaching a flamethrower to the nozzle. Yes, it creates a lot of fire and noise, but it is incredibly inefficient. To extract meaningful thrust from burning fuel, you need extremely high compression ratios. But the air reaching the back of the Campini simply wasn't compressed enough. Because it lacked that high-pressure environment, the aft chamber didn't so much harness the fuel's energy, it basically just dumped raw heat and unburnt vapour out of the exhaust nozzle. Engaging the burners did increase the top speed to about 230 miles per hour, but it drank fuel at a catastrophic rate. It was so inefficient that prolonged use of the rear burner would suck the aircraft's entire fuel reserve dry in a matter of minutes. As a fighter or a bomber, it was completely useless. It couldn't fly far enough to hit anything, and it couldn't fly fast enough to run away. Ultimately, Campini's thermojet was killed by the very thing it tried to avoid. While the Italians were flying their heavy V12 hybrid, engineers like Sir Frank Whittle in the UK and Hans von Ohain in Germany finally solved the metallurgical crisis. They developed high-temperature alloys that allowed turbine blades to survive the exhaust heat. Once the pure turbojet was perfected, it eliminated the massive weight and parasitic drag of the piston engine entirely. The continuous, self-sustaining loop was closed, and the true jet age began, leaving the motorjet in the dust. Today, the Caproni Campini N.1 sits in a museum, a fascinating artifact of an engineering transition. It was a spectacular failure, but a brilliant one. Secondo Campini proved to the world that a high-velocity jet of air could propel an aircraft across a country, even if he had to rely on the roaring, heavy brute force of a piston engine to prove it. Next time you fly on a modern jetliner, just be glad there isn't a massive V12 engine screaming away right behind the cockpit. Which bizarre piece of historical engineering should we look at next? Let me know down in the comments, and don't forget to subscribe.